So graph lines. The graph of an equation is a set of points correspond to all order pairs that satisfy the equation. It gives a picture of a graph of that equation. Linear equation in two variables. A linear equation in two variables, here x and y, can be written as ax plus by is equal to c. Again, this is a standard form. We're going to look at the linear equation in different forms again later, but this is a standard form. So graphing a graph of an equation is an illustration of the set of points whose order pairs are solution to the equation. Remember, we find some order pairs earlier. We can find few of those and connect them together, and that would be the graph of the line. So as you see here, in this case, this line, we have more than 2 points. You only need 2 points to connect them together, but all of these lines are collinear, all of them on the same line. Now, another important point about the line would be the x and y intercept. This would be the points where your line intercept x and y axis. Okay? To solve for y-intercept, the order pair would look like, if I call this number here A, let's say A. So this would be 0, A. So as you see, the point corresponding to the y-intercept would be on the x-axis. We're not moving anywhere, but on the y-axis we do move a little bit up here. So it would be 0, A. So if I let x equal to 0 and solve for y, that would give me my y-intercept. Now similarly, if I want to find the x-intercept, let's say this is B. Now at this point, this order pair here would be B, comma 0, because they're not moving on the y-axis. Looks like to find the x-intercept, I just have to let y be equal to 0. If I let y be equal to 0 and solve for x, that's how you can find your x-intercept. Finding intercept, when graphing the equation of a line, find the intercept as follows. If you let y be equal to 0, then solve for x, that would be your x-intercept. If you let x equal to 0, solve for y, and that would be your y-intercept. So let's find some intercept. Here our equation, 2x minus y is equal to 4. To find my x-intercept, I'm going to let y be equal to 0 and solve for x. This is equal to 0. It would be 2x equal to 4, so x equal to 2. So here it is. This is my x-intercept. So we're going to graph this line here. If I locate this point here, and similarly, if I find the y-intercept by letting x equal to 0 and solve for y, if I locate these 2 points, connect them together, that would be the graph of this line. Also, we know exactly where the intercept on my x and y axis. So let's locate the points here. 2x minus y is equal to 4. X-intercept is 2 and 0. If I let y be equal to 0 and solve for x, if I let x equal to 0 and solve for y, that gives me my y-intercept. Here 0 and negative 4. That's the point right there. If I want to find my x-intercept, I let y equal to 0 and solve for x. If 2x equal to 4, so x equal to 2. So these are the points of intersections. Connected together, that would be my line. Now, if I pick any other point, if I let x equal to 1, then I can solve the corresponding number for y, that would be negative 2. You see the point next one will be right on the same line. Let's graph 3x minus y is equal to 0. Let's find x-intercept. I'm going to let y be equal to 0, solve for x. If y is equal to 0, then would be 3x equal to 0, x equal to 0. You notice that in this case, your x-intercept passes through the origin and solves your y-intercept. If I let x equal to 0 and solve for y, you see my graph kind of passes through the origin. So sometimes it happens. Your line passes through origin, your x and y-intercept would be 0, 0. Here we're going to graph 3x minus and y is equal to 0. Now I need another point here because both x and y-intercept is 0, 0. If I let, let's say, x equal to 1 and solve for y, then I can see that y was equal to 3. So I find another point to connect them together, and that would be the graph of the line.